So our next topic is differentiability. Okay, differentiability means that we have to check whether a function is differentiable or not. Okay, so just like to check whether a function is continuous or not, what we did, we calculated LHL, RHL, and f of a. And if LHL equals to RHL equals to f of a, then we say function is continuous, otherwise discontinuous. Similarly, to check differentiability, that whether a function is differentiable or not, this is what differentiability. To check differentiability whether a function is differentiable or not, what we will do, we will calculate LHL, LHD and RHD. A function is said to be differentiable at x is equals to a if what is LHD is equals to RHD. Here D stands for derivative. D stands for derivative. That means left hand derivative is equals to right hand derivative. Where what is LHD? Where LHD. What is LHD? It is limit h tends to 0 f of a minus h minus f of a upon minus h. This is what LHD. And what is RHD? What is RHD? RHD is yours limit h tends to 0 f of a plus h minus f of a upon h. Okay, this is your what? RHD. Now try to understand what is this. This is also we said that this is f dash of a. Means derivative of function at x is equals to a, or you can also say that this is slope of tangent on the curve at x is equals to a, and this is also f dash a. But this is derivative is from left and this derivative is from right. And when we say that function is differentiable if LHD equals to RHD. Now try to understand what it means, what it represents. Suppose we have a curve. What is this? Very important point. Suppose we have a point, we have a curve this. Okay, say this point is x is equals to a and this point is say x is equals to a plus h. Try to understand the concept behind this. What is exactly the meaning of this? Why we say that this is slope of tangent? We use the word very frequently. F dash x represents what? Slope of tangent. Why we say this is slope of tangent? Okay, and in 11th we also see that derivative using first principle. Derivative using first principle. If you remember, what was the formula of derivative using first principle? It was limit h tends to 0 f of x plus h minus f of x upon h. This is also what? Here. Same thing. This, if you use x plus h minus f of x upon h, it is from right hand side. Okay. If you use f of x minus h minus f of x upon h minus h, that is from left hand derivative. Okay. So at particular point, if we are using this, that we are saying that it is LHD and RHD at x is equals to a. Now try to understand. Suppose x is equals to a, this function is y is equals to f of x. Okay, very deep concept, please focus. So it is x is equals to a. Now what will be the value of function at this point? F of a or not? Get it or not? Suppose we have a function f of x is equals to x square minus 7. So if you find f of 2, what it will be? 2 square minus 7. So either you can say it is minus 3 or you can say only f of 2. So at x is equals to a, this value is f of a. So this point will be what? A comma f of a. Very important thing we are discussing. Similarly, this point will be what? A comma f of a plus h. Okay. Now, if you find the slope of this tangent, this line, sorry, this is also called a secant. What will be slope of this secant? What will be slope of this? Say this point is A and this point is B. What is slope of line joining x1, y1 and x2, y2? x1, y1, x2, y2. What is slope of this line? y2 minus y1 upon x2 minus y1. So what will be slope of this line? MAB. What it will be? MAB. F of A plus H minus F of A upon A plus H minus y2 minus y1 upon x2 minus x1. This A is cancelled out. Now, what is the slope of this line? This What is slope of this line? Look here, it is f of a plus h minus f of a upon h. Now, very important thing. At this time, these 2 points are at far distance. Now, just think with point B is here. What will be h? H is decreasing. Suppose at point B is here. At limiting case, if we put the limit here, limit h tends to 0, this line will become tangent at this point or not? This line, when? Just look here again, once again. This is what? Second? This at this point it will also be a second. But when this limit h tends to 0, what it will be? When limit h tends to 0, what it will be? It is limit h tends to 0. In limiting case, it becomes tangent. This line becomes tangent. Okay, this becomes tangent or not? So what it will be? Limit h tends to 0, f of a plus h minus f of a upon h. So this is what? We are finding the derivative from right. That's why we are saying this is right hand derivative. Okay, at particular point. So at this point, what we have discussed, if we are finding derivative from right, now in the same way, suppose we have another point a minus h here. What will be this point if we find, say this point is C? What will be this point C? This will be a minus h. Sorry, it should also be a plus h. A plus h comma f of a plus h. So what it should be? A minus h f of a minus h. This point will be a minus h comma f of a minus h. So what will be? Again, we will have second here, another. This will be second. AC. What its slope will be? F of a minus h minus f of a upon a minus h minus a. So it will give you f of a minus h minus f of a upon minus h. And in limiting case, when limit h tends to 0, it will be tangent, slope of tangent. It will be what? Slope of tangent. Now, very important thing. If slope of tangent from both sides, from right side and left side, it is approaching to the same value, then derivative exists. If it is approaching to the different value, then we say limit, the function is not differentiable. Just take the example. Very important trick we have. Suppose we have a function like this. Very important trick for objective questions. Suppose we want to calculate differentiability at this point. Okay, now we want to calculate differentiability. If we apply this concept, what it will be? You will find derivative from this side, from this side, from this side, from this side, from this side. At limiting case, what will be? This will be slope of tangent. Yes. Similarly, if you find from this side, what will happen? This one, this one, this one, this one, this coincides. So we will say function is differentiable. Okay, now we take another example. Suppose we have this function. Now we want to calculate differentiability at this point. Now what will be left hand derivative? Some slope will be this, and from right hand derivative slope will be this. So are they equal? They can't be equal. This is left hand derivative, this is right hand derivative. When you find left hand derivative, it will be like this, and when you find right hand derivative, it will be like this. So they are not equal. So function is not differentiable. So very important trick. What is? Just see the curve and move your finger on the curve. If it is smooth everywhere, you will move your finger here. If curve is smooth everywhere, then it is differentiable because there is no sudden change in the slope. Okay, suppose just take a curve like this. We have a curve. Suppose we have a curve like this. Now, suppose what you say, this curve is smooth everywhere. So this is differentiable everywhere, but this is sudden change of slope here. This is sharp corner. This पिन सी चुभेगी यहाँ पे. When you move your finger, क्या हुआ? एक पिन सी चुभेगी यहाँ पे. जहाँ पे पिन सी चुभ रही है, function is not differentiable. So whenever you move your finger, and if curve is smooth everywhere, function is differentiable. If there is sharp corner or sudden change in the slope, function is not differentiable. So very important. So we know how to calculate limit. We have calculated continuity. Okay. So now differentiability is very simple. If you are very comfortable with limits, just we need to find LHD and RHD. If both are same, function is differentiable. If both are Not same, different, then function is not differentiable. For objective question, very important trick. Sometimes it works very fast. If function is smooth everywhere, then it is differentiable. If function is not smooth, it has sharp corner, then it is not differentiable. Very important thing. To be a function differentiable, it must be continuous. If function is continuous, then we will talk about differentiability. If function is not continuous, then we will not talk about differentiability. Second point, if a function is continuous, it may be differentiable, not differentiable. Look here, we have two functions. This is continuous and differential everywhere. You have another function, this one, it is continuous but not differentiable. So can you say if a function is continuous, it will be differentiable? No, it may be differentiable, it may not be differentiable. But if a function is differentiable, then what can you say about continuity? It will be 100% continuous. So if function is differentiable, then it will be continuous everywhere. Okay, so this is all about differentiability. How you check a function is differentiable or not.